All right, in this video, we're going to be talking about the line of best fit. If you look at the computer screen, you can see all I've done is I Googled definition, line of best fit. We're going to be talking about what is a line of best fit. We're going to look at some images. We're going to have a real quick conversation about line of best fit, and we'll wrap it up with, I'll give you some tips for your Khan Academy activity that aligns with this. So if we look here, line of best fit. What is a line of best fit? Well, it tells us. It's a line of best fit is a straight line that best represents the data on a scatter plot. The line may pass through some of the points, none of the points, or all of the points. Okay, so if you look at this picture, so we have a scatter plot, right, represented by all the little blue coordinate points, right? That's the scatter plot. And then this orange line that runs through the center of it is what we call the line of best fit. Now, we have lots of mathematical ways of figuring out what is the line of best fit. There's a couple different mathematical ways of doing that. In 8th grade, we never talk about those mathematical ways. We always talk about what we call eyeballing the line of best fit. You're going to have a Desmos activity that kind of gives you a 4-step process for creating a line of best fit. But in general, what you're trying to do is you're drawing a line that goes through the center of all of the points. You want to have about the same number of points above the line as you do below the line. And then as it said over here, some of the points might be on the line, but some of them might not be. And this whole idea that all of them are, that's a very unique case. For what we're going to be dealing with, we won't even be seeing this. That just means that you've just discovered a law. And if you were in the math world and you found if you were doing some research and all of the points landed on the line, you just discovered a law and you're about to be very rich. So that doesn't really happen in the real world very often. So normally what we see is that some of the points are on the line or none. Okay, and that's a very common misconception, is sometimes we feel like some of these points have to be on the line, but they don't, right? It can pass right alongside all of the points and not actually be on any of the points, and that's okay, right? This is just a line that kind of passes through the points, and it kind of gives us a general representation of all of the points. So you might be asking, well, what is its purpose? What does it really matter? So what we do in the math world, what we do is we create a scatter plot. We find these lines of best fits, and then we use these lines to make predictions. So like if you look right here in the graph, there's no data points. But I could make a prediction. So you can see it's talking about temperature on the bottom compared with sales. So there's no temperature here, but I could say, hey, if the temperature outside was about 21 degrees Celsius, we could predict to have about $500 in sales. Right? Now, does that mean if it's 21 degrees, we're going to have exactly $500 in sales? No, right? Because it's just an estimate. It allows us to kind of make a guess, right? So that's what we do with the line of best fits. You draw them in, and then you use them to make predictions about something. So let's look at a whole bunch of these. So I'm just going to click over here on the images, and we'll just look at some. Okay, so you can see on these images, we got a bunch of scatter plots, which means we have a lot of dots. It just happens that the ones that popped up are all positive, right? They all have positive sloped lines running through the data points. It doesn't have to. We'll scroll down and there'll be some other ones that are not. One thing before we get too much further I want to talk about is about the idea of a strong and a weak correlation. I kind of briefly mentioned it in one of the videos last week, but it has more to do with this line of best fit. So I kind of foregoed the conversation till right now. So a strong correlation just means that the points are really close to the line of best fit, right? So if I look at this one right here, this is a super strong correlation because all of the points are almost on the line of best fit, right? This one is a weaker correlation, right? they're kind of all around the line, but there's a little bit more spaces between there. Again, we have mathematical processes for all of this to determine all these things. And in 8th grade, we don't talk about that. We save that for the high school to get into all of that. So right now, it's just visually, what do we look at and what does it mean, right? Do we think it's a stronger correlation or a weaker correlation? And why does that matter? Because again, we're using these lines of best fit to make predictions. This one, right, since it's a really strong correlation, they're all on the point, I can make stronger or better predictions, right? So here, if the time was 45 minutes, I can be pretty sure that the distance is going to be 8 kilometers, right? Because everything is super close. I'm going to be pretty confident in that estimate with this one. Like if I looked up at this one, let's see if I click on it, if it gets a little bigger. So I don't even know what this is. This has something to do with chemistry, right? Look at these are chemistry things. So I don't even know. But the point being, if I had something that was at 62 here, and I made this prediction that it would be right over here at between 3.9 and 4, I'm not going to be as confident in that prediction because this is not as strong of a correlation, right? So that's the point of it, is if it's a strong correlation, we can be more confident in our predictions. If it's a weaker correlation, we're not as confident. Other than that, I'm just going to kind of scroll through and just talk a bit. You can see these don't have to be linear. Everything we're going to be dealing with in this year will be linear, but next year in algebra, you guys will start to look at a couple different types. Just to give you a quick heads up, that's kind of the idea. When you're in high school, you're going to start learning about different kind of functions, and kind of what people always say is, where am I ever going to use this in the real world? Well, this is actually how it gets used in the real world. We collect data. Data rarely ever falls in a perfect graph. But then what we do is we put a line of best fit, and then we look to see what kind of relationship is it. And then we can use those relationships to make predictions about other things, or to create, or to design, or to engineer, or whatever our purpose is for what we're doing. Coming through here and looking at some, I don't even think I've seen here's a negative right here. So, right, these can be positive, negative, nonlinear, just like we looked at last week. These images right here with these little lines, that's what we were talking about. That's getting into the math of how we actually predict how strong of a correlation is. How do we assign a number to it? It's called regression, and we're not talking about that this year. I think that's about it. Real quick, just again, positive, negative. Here's some more images on this idea of linear regression and using that to predict how strong or weak of a correlation we have. So that's pretty much everything I had to show you. The only thing I wanted to talk about real quickly before you do your Khan Academy activity is the idea of these nonlinear. On Khan Academy, if you cannot model the data with a single line, right? If all of the points don't fit nicely around a single line, right now we're just going to say it cannot be represented by a line of best fit, right? So there's going to always be 4 options, A, B, C, or it can't be modeled with a line. So again, it could be nonlinear, but we're not. So basically you could think, hey, if I drew in a curved line, I could model everything. Then that's when you would want to choose that it can't be modeled by a line. All right, as always, if you have questions, shoot me an email. Come to the Hangout help session. Make sure you're getting your questions answered. There will not be a a week of review before the test this unit. So if you have questions, let me know right away.